So chapter 2 is going to focus most on parabolas, about their properties, writing equations and such. So it's always a good idea to review the things we already know. So for example, if we take each of these functions right here, I should be able to use their shifting and reflection properties to match them to their corresponding graphs. So for example, if I was doing letter A, I know I'm looking at something that's upside down, all right, and the vertex shifted to the right too. So it's not A, it can't be C, it would have to be D. So if we look at letter B, it looks like it shifted right 2 and up 2, and it's not upside down, so that would be letter C. And then we could continue to go on. So upside, down, left, and down puts you at letter A. We do have a vertical shrink. That's really not going to matter so much because if we go right and down, there's only one graph that does that, and it's F. So then E would have to be B, and then F would have to be E. All right, so if we think about the quantity x minus 2 squared plus 2, if I asked you right now to FOIL that out, so I asked you to write x minus 2 times x minus 2, first, outer, inner, last, and then add 2, you could simplify that to x squared minus 4x plus 6. All right, so we need to be careful when we see something in this form. This is actually standard form. Standard form does not show you your vertical shift, okay? So you don't want to say, oh, it went up 6. Rather, we can tell from the original form it's actually shifted up 2. So it's right 2 and up 2. The good news about standard form is it tells you the y-intercept. So the y-intercept is 6. So it's really important to not get these two forms mixed up. They each have different things that they show, and we want to make sure that we know what things are being shown. I will tell you, the first one, the x minus 2 squared plus 2, that is more helpful when you're graphing than standard form. Okay. Why is that? Because you can tell me the shifts that took place. So we have quite a few vocab words, and I'm going to go a little quickly through them. All right, quadratic function, anything that has an even degree. So if its largest exponent is even, all right, so I don't mean like 1 over x squared, I mean like x to the 4th, x squared, x to the 6th. If the highest exponent is even and it's not a reciprocal function, then it's a quadratic. A parabola, if you recall, is the shape that results when you graph a quadratic function. So there's no such thing as a parabola function. Parabola is just the name of the U shape that results. We're going to use vertex a lot. Vertex is the key to doing any kind of word problem. So depending on whether your parabola is normal or upside down, it's going to be the highest or lowest point on your function. It's also the point where the parabola could fold over on top of itself. And what we have to understand is in this class, your parabola is going, or your vertex of your parabola is going to be h comma k. So wherever the x coordinate is of the vertex, that's called h, and k is the y coordinate of the vertex. Vertex form, super duper helpful, very important. F of x equals a times the quantity x minus h squared plus k. And this is what you guys have been graphing with no calculator. You have been graphing vertex form. So as you can see, it makes it very easy because you can see right or left and up or down. Right. Your axis of symmetry is basically where the graph is symmetric. So if I were to draw a parabola right now, okay, this would be your vertex, and its ordered pair would be h comma k. And all you have to do if you want the line of symmetry is just draw a vertical line right through the vertex. So your axis of symmetry is always going to be x equals h, because h is the point of symmetry. Okay. And then we have standard form, so typically it's ax squared plus bx plus c. So it's kind of like the standard form for a line. Before, for a line, you had ax plus by plus c. So it kind of follows that ideology, but this time there's no y's because we have x squared and x's. Minimum would be if you had a normal looking parabola, so like that. The vertex is your minimum because it's the lowest point that's on the graph. All right, if your graph is upside down, well then your vertex is not a minimum, it's a maximum. That's all that means. All right, let's quickly review. How do A, H, and K affect your graph? Well, if we remember about the number that's in front, right, if it's like a fraction between 0 and 1, it's a shrink, it's a vertical shrink, and if it's bigger than 1, it's a stretch. All right, if you see plus inside, that means we go left, and if we see minus inside, that means we go right, unless x is negative, and then we know we have to, if we're working with a backwards graph, we have to work with backwards horizontal rules. Right, and then the K tells you how much you go up or down. So we're going to kind of talk about why vertex form actually makes sense, why you can actually see where the vertex is based on vertex form. Like, why does this work? So what I'm going to do first is make a table. I'm going to use the following values. So if you notice, I put 9 in the middle because 9's in the parentheses, and I put two numbers both bigger and two numbers smaller. All right, so what happens when we put 11 in for x? Well, 11 minus 9 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 10 is negative 2. Okay, so if I put 10 in for x, you'll find that you're going to get negative 8. So if I graph my ordered pair, 11, negative 2, we're going to count by 2's, 2, 4, 6, 8, 10, 11, and 2. And then I'm going to graph 10, negative 8. So 10, 2, 4, 6, 8. Right? If I put 9 in, what happens? Oh, this all becomes 0. So I get negative 10. Okay, cool. And I'm going to try using 8. And what you'll notice is you get negative 8 again. And if you use 7, you end up getting negative 2 again. So obviously I should see a parabola start to emerge, right? Just like it is right here. So the question is, if you were to keep building onto this table, whether you pick numbers bigger than 11 or smaller than 7, what's the minimum output you would ever get? Well, there's two ways to think about that. You could just physically look and see what's the lowest point, or you could remember the fact that the vertex is always going to be the minimum. Right, so in this case, negative 10 is going to be the minimum output. There's nothing you can plug in, so you get something smaller than negative 10. That's never going to happen. So what that means is your minimum output is always going to occur when your parentheses equal 0. All right. So when your parentheses are 0, that's how you're going to get the minimum number. Why is that the case? Because no matter what you do, no matter what you plug in for x, you're always going to end up getting a positive outcome. So if you plug negative 100 in, you're going to square it. It's going to become positive. All right. So the smallest number in the parentheses you can get would be, after you square it, would be 0. All right. So what that tells me is, okay, well, since I know that 0 will make a minimum, but minimum is also vertex, whatever makes 0 is the vertex. So whatever I plug in for x to get those parentheses to be 0, that's going to be my h value. So we have several examples here that we're going to practice finding the vertex, telling me whether it's a min or a max, and identifying the axis of symmetry. So I'll kind of help you with a couple, and then I'll see how you do on your own. Alright, so the first thing you want to realize is if there's a negative in front, it's like a frowny face. So that right away tells me that my vertex is a maximum. Right? It's going to be the highest point. So just like you're moving when you're graphing, you know you go right 1, so that'll put you a positive 1, and up 4. So that's your vertex. So if I ask you what's h and k, you would say h is 1 and k is 4. And then your axis of symmetry is always going to be x equals h. Jump down here to letter E. Right? It looks a little different because it's not in vertex form. But that's okay. We could turn it into that. We could separate negative 2 And we could change x to x minus 0 if we want. So I have not changed the problem. This is still x squared times negative 2, which is what I have here. It just looks a little bit more normal to me because it's in vertex form. So because this number out front is negative, it's frowning again. So it looks like we're going to have a max. We would go right 0 and up 3. So that puts you at 0, 3. And then your axis of symmetry is x equals h. I'll take you through one more here, letter H, because we're going to be careful here. So if you notice, we have a negative inside, not outside. So this graph is actually smiling. All right, but we know to be very careful with negative x's because this is actually reverse of what you'd normally think. So normally we would think, oh, you go left 2, but actually this means right 2. So we would go right 2 and down 1. It's going to be a minimum, right, because it's the lowest point on the graph. And the axis of symmetry is going to be x equals h. So what I'm going to do is I'm going to pause the video and do up the rest of the problems quick. You can pause the video, do up the rest of the problems, and then we can compare answers. All right, you can take a look. Hopefully these turned out okay for you. If you notice in letters D and I just inserted a plus 0 at the end. That way everyone had a value for my normal vertex form. And hopefully that was okay. So in my next video, I'll go ahead and take you through the rest of the notes. I think this video is long enough.